Now we're looking at the active cutting process here behind me. The 5x10 sheet, 1.5 millimeter or 040 mild steel. We got a mix of small intricate parts similar to this one, where we remove all the internal slugs automatically. They get dropped down below the sheet and separated from the part. Every single opening in a final part, every single slug will have fallen. The machine has integrated sensors to detect if a slug would not be successfully cut. It doesn't recut automatically. It traces that so that we make sure every part that comes out is actually a good part. Some other pieces we see, the larger contours, those are parts that will get removed by our SortMaster Speed, the integrated automation unit. It has 2,772 small suction cups across 6 shuttles altogether. Those larger parts will be removed and stacked on a pallet that later goes in our large storage system and is automatically prepared for the next operation. In this case, it will be bending. What we also witness is that the cutting unit, like I said, moves along the long side of the sheet while it has still a little axis. It's called the additional axis to YP that moves also in Y. You see that very good when it's cutting. It has very short, high acceleration, high jerk movements to cut those intricate contours, and it allows us to do like a superimposed movement of the large sheet that moves at a certain rate, and then we superimpose a short axis to do the intricate geometry.
And you can combine the laser head movement with the movement of the handle, correct?
Absolutely, yeah. So that's exactly what is happening. Like the sheet moves in one direction, the laser unit moves in the same direction, but at a much higher acceleration and much higher speed for like little corners and sharp corners, while the whole unit moves along the x-axis. So this overlay is similar to a punch combination machine that you might know, that creates the final geometry. And what it allows us is to always guide the laser between the SmartGate, like I said, always support the part that we never have tip-ups, and eventually allow the automation unit to come in close to it and remove the parts for stacking, which is exactly what we're going to see right here.
What's the material, Andreas?
The material here is mild steel, 1.5 millimeter.
Wow, okay.
We can do, all the standard materials, aluminum, mild steel, stainless, copper, brass, no problem.
Okay, so reflectivity is not a problem at all.
Exactly, yeah. We're cutting with a true fiber laser, so reflectivity and cutting like colored material, as I want to call it, is not an issue.
Okay.
The limitation is basically sheet size, sheet thickness, and that brings total sheet weight to roughly 512, 520 kilogram. Of course, because it's a sheet dragger, naturally weight has an effect.
Yeah.
So that's why we weighted the machine and developed it for ½ inch, which is 1 millimeter to ½ inch is quite a good amount to cover fully automated. Yeah, and as you see, this combination of larger parts, smaller parts, the large parts get carried away, and we'll make a take where we see the stacking on the other end of the machine, while the smaller parts, they get extracted underneath. So I'll demonstrate that here. So let's just say this part is ready, it's finished it has finished cutting, the SmartGate just opens and the part falls through the chute underneath into one of the sorting bins or our conveyor that brings it to the final location.
And the bins are underneath, is that correct?
Bins, we have to go down a little bit.
Yeah.
We have here our cart, our trolley to pull out 8 bins where small parts can be sorted and counted. And then on the back of the machine, there's a large container where a conveyor feeds parts into it. That container is typically used if you have a high runner of relatively small parts. Now, we say small, anything 6.2 inch square and smaller. This is a small part. that we can reliably remove, sort, count, and book to one of those containers.
Okay.
The largest part we can sort, as I said, is 5 by 8. The smallest part that we can sort here is actually the size of a credit card. So the size of a credit card is already enough that our automation unit takes it out, pulls it away, and stacks it. And maybe we walk over.
Yeah. And that's it right there, right?
Exactly. So we see 3 shuttles of the SortMaster Speed parked here in front. Each shuttle has multiple handheld suction cups, has integrated sensors to detect when we have successfully removed the part and only carry it away once the removing was successful.
Yeah.
Now somebody might ask, well, how do you make sure? Because if operators at the moment clean as parts, sometimes you have to wiggle a little bit, or not everybody cuts simple, nice rounded parts.
Yeah.
And that's a very good question. Now the TruLaser Center has multiple retry steps that will automatically be carried out. If the sensors detect that we didn't separate it on the first try successfully, there's 8 stages it runs through. Adjusting vacuum, adjusting air pressure, releasing the part again, picking it up again. We even imitated the actual shaking of the part with the automation unit to make sure it releases from the skeleton.
And there we go.
Exactly.
Just what you were talking about.
And now all the 6 shuttles worked in collaboration to carry it away. And the best way to explain what is happening is, if you think about a puzzle, everybody has built a puzzle at one point, right? And somebody asks you to remove a piece, but it has to be a centerpiece where all the other pieces are already in place. You will hardly be successful only grabbing it from the top. What naturally us humans do, we take one finger and push a little bit from underneath, and then this one piece breaks free and we grab it from the top. Now this is precisely what we map to the TruLaser Center. The brush table, which is static and not moving, also allowed us to place pins underneath. Those pins are being programmed by our boost programming system, knowing the geometry, the center of mass, the outline, the holes, just everything about the part. And the pins will push the part out of the skeleton while we hold it down, right? And this sandwich is something that prevents parts from tilting. If we would only push, of course the part would go anywhere. If we would only pick from the top, we'd most often also contact the skeleton, and the vacuum is established between the skeleton. But by holding it down and then pushing only the part up, the skeleton remains flat, we create a sandwich, and only once we have it separated in that fraction of a second, then we activate vacuum and carry it away. Now this technology allows us to use those 2,772 suction cups, but nobody has to program them individually, which would be a programmer's nightmare.
Oh, yeah.
Right? They have passive vacuum technology integrated, so only the vacuum cups that are actually in contact with the final part, once it's lifted out of the skeleton, they will establish vacuum. All the other ones sense air and then shut off in a matter of milliseconds, so that we have a safe transportation and without sucking the skeleton.
Cool.
Yeah, maybe we walk over one more step.
Sure.
And see the final location. So this is where our little bit larger parts go. Like I said, up to 5 by 8. In some cases, we can even do parts that are up to 10 feet long. Not the full size, because it's a function of material properties, size of the part, and thickness, of course, right? And then some customers might have more cutouts, more geometry that is removed. Others have more continuous parts. Now, what we just witnessed is actually, it was the internal contour of the part. Now that internal contour, those go into the box here at the bottom. And why do we do that? we have two possibilities to get rid of internal contours. We can cut them up into small pieces, put them down in our scrap conveyor and into the scrap container. But that happens in main time, so it actually takes quite some seconds to destruct the part. And for internal contours that are like the internal of a window, this would be very inefficient, right? If somebody wants to cut this piece here, and all that green area is basically scrap. So what we did is we put a bin here, we defined this internal piece as a part, but as scrap part, and the automation unit will take it away, just cut the outside and drop it here into the bin. Now nobody says this additional container only can contain scrap pieces. Of course, you can use this also to take away other pieces, other parts that you say, hey, that's actually good. It gives me another alternative, another sorting location. I don't need them sorted, stacked, counted nice and neatly to be forwarded to bending. I want them in a container where I can just take a pallet jack and carry them, I don't know, to which operation in your business is next. But it just allows for flexibility. And that is something that we always highlight and teach also in our training classes here in Chicago, where we teach operator and programmers to make the most out of the TruLaser Center. Like right tool at the right time or the right feature at the right time. That is how we encourage and allow our customers to get the most out of this machine.
But still, even for scrap, those are piled pretty neatly.
Yeah, you could say for scrap it looks pretty good. That's fine. Yeah, I think that covers the main processes. Like I mentioned earlier, these parts here on a pallet, they will later get transferred to our large storage system, where we have multiple hundred of those shelves. Some of them you see at the top or in the middle section here, they have wood skids on it. They don't have yet parts. Some more on the left side behind our gripper wall. There is already parts, there is sheets sitting on it. This allows for very flexible manufacturing and integrated cutting and bending that directly connects the cutting, the forwarding, and then later the bending process. This is one of the prime advantages of the TruLaser Center, that we enable other technologies to do what they can best by doing what we do best, cutting and sorting fully autonomously without even pressing a button. And yeah, all the time while we chat here, the machine is just doing its job. Nobody is really operating it. There's no person on the shop floor. And yeah, that's about it.
All right. Thank you, Andre.